All right, what do you want to see from the homework? Homework. Does that mean last night's homework was better? No, it doesn't mean that.
I was reading.
Number 11. All right. Number 11. All right. I know well, let's see, what are we supposed to be rotating around? Rotating around the y-axis. Alright. So I basically know what y equals square root of something looks like. And rotating around the y-axis is vertical. We're using the shell method, so what kind of rectangles do I need? Vertical rectangles. And when I'm using vertical rectangles, is everything in terms of x or in terms of y? In terms of x. So far so good. I have what I need, the function in terms of x. I could find out what x equals when y equals 0, or when x equals 4. When x equals 4, y would be square root of 3. And if I want to find the x-intercept for this, to see where y equals 0, then that equal to 0, and I get x equals 5 halves. So I've got the x-intercept and the point where it hits the line x equals 4. Square root of 3 is just a little bit less than 2. And so it's this thing right here. Double check. X-intercept 2.5. The point 4 square root of 3. Y equals 0 is the x-axis. And I'm going to rotate that around the y-axis. So the good idea I had yesterday, just getting on into the color thing, is highlight the piece that I'm rotating, and then use vertical rectangles. So, since we're using rectangles parallel to the y-axis, we're creating shells, and I know when I use the shell method, the volume is 2 pi times the integral from what to what. Left to right. Yes, I'm starting at x equals 5 halves, and that representative rectangle is sliding from 5 halves up to 4. So 2 pi times, add up all the rectangles from 2.5 to 4 of, what's the radius, if this is being flipped around the y-axis, what's the radius of each shell? From here to here is going to be the radius. And that's x, some x for each little rectangle. So x times, then the height of each rectangle is what? Okay. Can you tell me what was bugging you about that, or it was just? Oh, okay. The 2.5 to the 4. Okay. All right. Any other homework questions? 17. Yeah, I understand that. The good thing about what we're doing right now, every day is supposed to reinforce, make you just a little bit stronger on what you did the day before. So you should be better at 7.2 today than you were yesterday. And then tomorrow you'll be better at 7.3 than you are today. It's just kind of a delayed gratification thing. Y equals x cubed, x equals 0, y equals 8, and we're rotating about the x-axis.
Can you just remind me what you talked about in class? I wasn't sure what shape
Okay, let's look at it. When we get to problems where we're doing, they just say find the volume, and we have to decide whether to use the shell method or the disk method. There are some that say use the disk method. There's probably 2 that say use the disk method, 2 that say use the washer method, and then 2 that say use any method you want, just give the answers. Yeah, those numbers probably aren't right. But yes, there are some that specify and then some that say use any method. So I'm going to start preparing you for the use any method. And here's how I think about which method to use. If I'm rotating around the x-axis is horizontal. And like Cheryl, my favorite rectangles are vertical when I can use them. I'm more comfortable with things in terms of x instead of terms of y. So if I'm rotating around the x-axis and I have my choice of methods to use, I'd probably use the disk method because I'd rather have rectangles that are vertical, just perpendicular to horizontal, rather than parallel. If that was just mixed and said use any method you want, that's the method I would choose, the disk method. If you tell me I have to use the shell method, then I know if I'm rotating around the x-axis and using the shell method, then I'm going to use horizontal rectangles. And writing every little thing down helps me. I mean, maybe y'all can keep stuff in your head. Stuff doesn't stay in my head very long anymore. I don't know if it ever did, but it certainly doesn't now. So horizontal rectangles, and that means everything in terms of what? All right. So everything in terms of what? Well, right off the bat, I realized that's not what I have. I have y in terms of x instead of x in terms of y. But that's pretty easy to solve for x. And there's my function in terms of y. And let's see. Go ahead and graph that. Cube root of y. I know cube, let's say. It's easier for me to find some points first, yeah. If I let x be 0, I get y 0. It definitely goes through the origin. If I let y be 8, what's x? 2. And so there's 8 somewhere up here. And it's easier for me to think y equals x cubed than x equals cube root of y. I know what y equals x cubed looks like. The other messes with my head. So I just draw a little piece of what x cubed would look like from 0 to 2. And it can hang up, I know it continue down, but that's the little piece from 0 to 2. All right, and make sure I'm rotating the right thing. This piece of the graph and the x-axis or y-axis? Well, x equals 0 is the y-axis, which is why I need my highlighter to say this is the piece I'm rotating. Bounded by the y-axis, not the x-axis. If it was it is bounded by, if it was bounded by the x, then I'd be rotating this piece down here. All right, so highlighting helping me. X cubed, the y-axis, the line y equals 8. Rotate that around the x-axis. So down here somewhere, there's going to be -8. And, it's so hard for me. I don't know why that's hard. It just is. That's what it would look like when I rotated. And since I'm using the shell method, and we've already written down, I want horizontal rectangles. Here's one representative rectangle. And since I'm using shells, I'm saying v equals 2 pi times the integral from, be careful, these are horizontal rectangles, everything in terms of y. What are my bounds of integration? With horizontal rectangles, they're sliding up from 0 to 8. What is the radius of each shell? That's not the. Well, the radius is this circle. When this circle is, when this rectangle is close to the x-axis, I have a shell with a tiny little radius. As that rectangle slides up, then my radius is getting bigger and bigger. So my radius is determined by whatever y is for each rectangle. What you were giving me was the height, and I need that also, but the radius is just y. And then what should I use for the height of each rectangle? I'm not using vertical rectangles, so I don't need this 8 minus anything. It's just what's the right side of my rectangle touching, what's the left side of my rectangle touching. And the right side of my rectangle is touching cube root of y. The width of each shell is dy. And as far as I'm concerned, you get the prize right there, and you punch it on the calculator to give me the value. All right? We'll do a different kind. McKenna, would you give this to Jordan, please? Jordan, that is the examples that I emailed you just in case you couldn't print in color. 7.2, that top paper you're holding, I have found the secret to the disc method for me. What I have on that paper worked every time. And it's just drawing the rectangles differently than they drew them in the book. It was helpful. So study that sheet in the green and red on the next page. I know the Miles method. Miles method is always best once I discover it. But sometimes the hardest part of teaching something that's difficult is learning to put it into words. You know, it's a little bit easier to be on that side of the desk for right now. All right. So at the top of the back page of the notes, we have our generalization of the shell method, whether we're using vertical rectangles or horizontal rectangles. And yay, that would be fine if we were always rotating some area with respect to a coordinate axis, either the x-axis or y-axis. Copy. All right. So we'd be through with this section if all we were going to do is rotate around the x-axis or the y-axis. And again, the difference between the disk method and the shell method is the disk method, the rectangles are perpendicular to the axis of revolution. The shell method, the rectangles are parallel to the axis of revolution. And in both of those cases, horizontal rectangles means everything's in terms of y. Vertical rectangles means everything is in terms of x. And then I know when I'm using the disk method, it's basically v equals pi r squared. Add up all the rectangles, but we're using v equals pi r squared. For shell method, we're using the circumference of a shell rather than the area. So 2 pi r squared is how it begins. All right, so here's my little dang it face. Dang it. Not all solids of revolution are centered at the origin. Why? Or formed by rotating a function around the x or y axis. So let's see if we can figure out this formula. Come up with it ourselves. Consider the solid formed by revolving the region bounded by the graphs of y equals x cubed plus x plus 1. That's a little piece of it right here. Y equals x cubed plus x plus 1. Y equals 1, this horizontal line. X equals 1. That's the right boundary of the shape that we're revolving. And the line x equals 2, or about the line x equals 2. So we're whipping this around the line x equals 2. And because our axis of revolution is vertical, and because we're using the shell method, my rectangles also need to be vertical. And vertical rectangles means everything needs to be in terms of x, which, yay, I have, because otherwise I'd be hard to solve for x. Okay, what's the thickness of a shell formed by a vertical rectangle centered at x? Here's my vertical rectangle. What is the thickness of that shell? Well, the thickness of the shell is always delta x. And as you have more and more and more rectangles, the thickness of each shell is getting smaller and smaller. So that's where integration comes in. That delta x is going to be going to 0. I took the easy part to leave the hard part for y'all. What is the radius of this shell if this thing is being whipped around the x-axis? From here to here is the radius. What is it? For a rectangle centered at any value x. This is going around the line y equals 2. So what's this distance from here to here? 2 minus x. From the axis of revolution to the center of each rectangle. Now these rectangles again are sliding from left to right, but wherever that rectangle is, there's some x value in the center of it, and the distance from x to 2 is 2 minus x. And what is the height of that shell? For any given x, what gives us the height of that rectangle? This integrated all the way down to the x-axis. Because if I just integrate this, I'm going to get all the way down to the x-axis. Is that what I want? I want to stop it where? At 1, at y equals 1. So what gives me the height of that rectangle? All of this minus 1. I'm touching, again, what's the top of my rectangle touching? The function. What's the bottom of my rectangle touching? Y equals 1. So x cubed plus x plus 1 minus 1 is just x cubed plus x. So what definite integral would give me the volume of infinitely many such shells added up? The volume would start with what? 2 pi times what? It's where my x's are sliding from 0 to 1. Good. The radius 2 minus x. Yep. For reasons I'm uncertain of, the author calls this distance, I want to call it r. It's the radius. P? What? I don't know why. I don't know why. But P is the distance from the center of the rectangle and the axis of revolution. Well, so label this P. P is the distance between the center of each rectangle. The center of each rectangle is going to be some x value. The distance between that x value and the axis of revolution, 2 minus x. That's the radius. And like I said, for reasons unknown to me, that's P. I'm only using the P so that if you look on CalcChat, you'll understand what they mean by P. P is the radius. I don't know why, but P is the radius. CalcChat's your friend. And then the x cubed plus x is the height of each rectangle. What does the top of the rectangle touch? What does the bottom of the rectangle touch? And yay, guess what they use for height? H. Yeah. So, let's do the vertical axis first. If we are rotating around a vertical axis, like we were in the example we just did, then we're using vertical rectangles because our rectangles are parallel to the axis of revolution. P is the distance between the center of the rectangle and whatever the axis of revolution is. So it's going to be x minus something. And height is the height of the rectangle. What's the top touching? What's the bottom touching? And then when we're rotating around the horizontal axis, because our axis is horizontal and we're using the shell method, our rectangles are going to be horizontal. Everything needs to be in terms of y. P is the distance between the center of the rectangle, and the axis of revolution from here to here. So it's going to be y minus whatever the axis of revolution is. This distance, this is some y value. I don't know what it is, but the distance from this y value to this constant is this y value minus that constant. And then h is the height of the rectangle in terms of what's it touching on the right side, what's it touching on the left side. All right, let's try some. Number 24. All right. Number 24, we have y is the square root of x, y equals 0, and x equals 4 are the boundaries for our solid, and we're going to rotate about the line x equals 6. And here I'm told which method to use, so I'm not going to eeny, meeny, miny, moe. I'm going to rotate around a vertical axis, and if I'm using the shell method, that means my rectangles are going to be what? Yay, I like vertical rectangles. And vertical rectangles means everything's in terms of x or everything's in terms of y. No, that's not my favorite, but okay. In terms... No, that is my favorite. Yeah. Because that's already in terms of x. And so I have the equation in terms of x. When y equals 0, x would be 0. And when x equals 4, y would be 2. And we know what square root of x looks like. From 0, 0 to 4, 2. It's the top half of a sideways parabola. So the part that I'm rotating is going to be bounded by y equals square root of x, y equals 0, which is which axis? The x-axis, and x equals 4. This is what I'm rotating. And I'm going to rotate it about the line y equals 6. So over here, there's going to be the mirror image of that. To the very best of my ability. I'm going to get this thing with a hole in it. I really can't picture what that would look like to you. How many of y'all can? Because I know some of you have mental power. You can see? Okay. Does everybody but me see? You can, Michaela? Wow, yay.
I can't see anything.
We're such sisters. Cheryl.
It reminds me of those cat toys where it slopes up and then there's like a jug in the middle where they have the mass that all can jump out and like combine.
I don't think I've seen that.
Yeah,
Interesting. But I can picture what you're saying.
That's what it is. But like if there wasn't, it would just like straight down.
You don't really have to, Cheryl, or I wouldn't be here. What I'm saying is, you can do this even with the handicap that I have of not being able to see things in 3D and rotating. You can do it anyway. So, since we're using shells, I'm going to say volume equals 2 pi times the integral of, I didn't draw my rectangle, a vertical rectangle, centered around some value x, and x, the rectangles are sliding from 0 to 4. So that's my bounds of integration from 0 to 4. And then what is the radius of the solid? It's the axis of revolution minus The center of each rectangle.
Which is fine.
Yeah, the center of each rectangle is just X. So from here to here is my radius. And for reasons unknown to me, that's P. And it's 6 minus X. That's the first factor of my anagram. And then the other factor is the height of my rectangle, which is what's the top of my rectangle touching, what's the bottom of my rectangle touching. Just square root of X minus 0, or square root of X. And what is the width of each shell? And I feel like this is not so bad. Maybe I know I'm teaching it better because it's my second semester of teaching it rather than my first semester of teaching it. The highlighting helped me on these, and the labeling, the radius, and the height helped me on these. Any questions? All right. I'm feeling kind of cocky. That's usually when I mess up.
Now it keeps me humble.
I know. Me too. Me too. But then, you know, my little baby college algebra students go, she's a math genius. No, I'm not. There's really limits. You just haven't seen the limit yet. You'll see limits when you get to calculus. Okay. That was, what, 24? So 26. Y equals 1/3 x cubed, and y equals 6x minus x squared, about the line x equals 3, and it says use the shell method. So I'm thinking my axis of revolution, is it vertical or horizontal? It's vertical. And so if I'm using the shell method, my rectangles need to be vertical as well. They need to be parallel to x equals 3. So I'm using vertical rectangles. Yay, I like vertical rectangles. Which means everything needs to be in terms of what? In terms of x. Which, yay, is what I have. Thankful for every little thing God gives me here. Yay, I have a function in terms of x. All right. Just things make me happy. What do you think I need to do? I'm probably going to have to find points of intersection. I know what this piece, the second piece, is a concave down parabola. The first piece, I know what x cubed looks like, but I need to find out where they cross so that I get my bounds of integration. Now, after I woke up from my nap yesterday, I spent about 3 hours answering emails, and so it was 8 o'clock before I got to start looking at day 2 of the shell method. And I encountered 2 questions that I could not think of the answer to. I don't know if it was because it was my bedtime already or what. But this problem has one thing that I'm going to either have to think about some more or phone a friend after class and go, I don't understand why something. All right? You'll see what it is in just a second. Three points of intersection. coming from x plus 6 equals 0? Well, I'm not even thinking about those. I'm trying to find the point of intersection of those two graphs, and there are 3 points of intersection. When x is 0 in either equation, y is 0. When x is negative 6 in either equation, y is, I think it was negative 72. And when x is 3, y is 9. All right. So those 3 points of intersection, 0, 0, 3, 9. Negative 6, 7, negative 72 is way down here somewhere. Well, this is where something bothered me. I know what x cubed looks like from this point to that point. And I know what a concave down parabola would look like from this point to that point. Ooh. Yeah. Ooh, let's just make it just a little bit. It has to. It has to go. It would be nice to have that in 2 different colors. I'm proud of me. With no graphing calculator, that's pretty good for what that looks like. Okay, here's the thing I don't understand. We're supposed to be rotating the area between those two curves. That's all the instructions that I'm given, between those two curves, and around the line x equals 3. X equals 3 is right here. So that's getting rotated around this line. My question is, why aren't we rotating both pieces? In the solutions manual, they've only rotated that. And I have no explanation for that. Because remember, we missed a problem one day because we were rotating half a parabola and we were supposed to be rotating the whole parabola. Well, I don't understand what's telling me to disregard this piece here. So I'm going to have to ask, unless it comes to me sometime between now and 10 o'clock, I'm going to have to phone a friend who's smarter than me and go, I don't see, actually.
Miles.
What?
I'm smarter than your friend.
I don't understand why we're not counting that piece. There's nothing in the instructions that say bounded by the x-axis. Now, if you said bounded by the y-axis, no, it still wouldn't work because that's bounded by the y-axis on the right, that's bounded by the y-axis on the left. I'm not sure what words would have to be included to make it perfectly clear to me that why I'm only rotating this portion.
I just assumed it was that portion.
Yeah.
When I was working it out, but there's no reason for that.
Yeah, I did too until I got 3 points of intersection and I said, whoa, there's another piece over there. Why am I not rotating that piece? And it's like forgetting the other half of the parabola in the other problem. All right, so I'll come up with a good answer to that and let you know tomorrow. There was one other thing that I swear I think is a typo. Ooh, actually it was in last night's homework, so I'll see if you encountered it. I mean, you didn't ask me about it. So,
Time to check
yeah.
the work again.
Okay, all right. Whew. We said we're using vertical rectangles. They're sliding from where to where? If we assume we're only using the right portion. From 0 to 3. Little vertical rectangles that are sliding from 0 to 3. The center of each rectangle is at X. On that side. So my volume is going to be 2 pi times the integral from what to what. Those rectangles are sliding from 0 to 3, so that's where I integrate. What is the radius of each shell? 3 minus the center of the rectangle, which is at X. Yes, ma'am. You're saying a red rectangle and a green rectangle like I did yesterday. X is just the center of each rectangle. I'm trying to think what I can. If I had some of that bendy styrofoam like stuff that comes in different colors, then the thickness of it would be the dx or the dy thing. Imagine one of those curved into a shell from the center of the rectangle to the center of the exterior portion. That's going to be the radius of the shell. And then the height of the shell is determined by what the rectangle is touching on top, what the rectangle is touching on bottom. Now, if we were using the disc method, I would do exactly what you said. This would have inward concavity. And so I would draw me for one thing, if I was using the disc method, I'd have to have horizontal rectangles. But I would draw a green triangle all the way. This would be what's making the exterior surface. So I would draw a green rectangle that touched this function and the axis of revolution. And then I draw a red rectangle that touched this and the axis of revolution. But here, the height of my rectangle is just let's see, which one's on top? The parabola? Is that that's the parabola on top. It's touching the parabola on top and the cubic function on the bottom. So the height of each rectangle is what? Mm-hmm. So that's my other factor. Negative 1/3 x cubed minus x squared plus 6x. And then the thickness of each shell. I've been saying width. I really should be saying thickness of each shell. It's the thickness of the piece of styrofoam that I'm building around. And someday, my third or fourth attempt at Cal 2, I'll figure out a way to have some manipulatives here. My ex-boss, Dr. Pomper, was saying he teaches this with Play-Doh. I said, I'm not there yet. I can't do it with Play-Doh yet. But I think it would be helpful if you could bend something and see the shells. Okay. Yeah, this is going all right. I think I got it. As soon as I say that, I look at where I wrote the answer last night, and it's not the same thing. It probably is the same thing. 2 pi integral from 0 to 3, that's p, and that's h and dx. Yay! And so here's the little note that I wrote last night. How do we know we don't include that other little piece? That's what I'll ask somebody today. I think that should not be assumed. There is nothing in the instructions that tell me to disregard that piece. I know, and I would have a hard time flipping that around the line x equals 3. But either I want to know why it's not included, or I want to change the problem to add some wording to make it clear why this piece shouldn't be included. I don't like things that aren't clear because I'm a mathematician. I'm a teacher. All right. So we have two methods now. Why do we need two methods, and how are we going to decide which method to use on each problem? Well, some of the problems on the test will say, use the disk method, use the shell method. And I like it when somebody tells me what to do. I follow these instructions well. It's harder for me when I have to figure out which method to use, but I'm kind of getting the feeling that, if you give me a function, let's say this one, there was one a minute ago that would have been hard to solve for x. Well, if you give me a function in terms of x, and it would be hard to solve for the function in terms of y, that's kind of going to determine that I want vertical rectangles because my function's in terms of x. And if I use vertical rectangles, then the orientation of the axis of revolution is going to determine whether I use shell method or disk method. If I've already determined I want to use vertical rectangles, and then I have a horizontal axis of revolution, what am I going to have to use? If my rectangles are perpendicular to the axis, I'm going to have... Disk is when your rectangles are perpendicular to the axis of revolution. Like this, my axis of revolution was vertical, so my rectangles were vertical because I was using the shell method. But if you give me a function in terms of y, then, and it's hard to get it in terms of x, I'm thinking, if it's in terms of y, would I be using horizontal rectangles or vertical rectangles? In terms of y always indicates horizontal rectangles, and so then I would look at my axis of revolution. If my axis of revolution was parallel, and I wanted horizontal rectangles, what method would I have to use? Shell. Shell is when your axis of revolution is parallel to your function in terms of y, or parallel to your rectangles. If I had a function in terms of y, but my axis of revolution was vertical, then what method would I use? This method. That is pretty much summed up. Where is that summed up? In two places, actually. One of them is in your book. Here it is. I'm not sure what page that is in your book, but it's at the very end of 7.3, a little blurb comparison of disk and shell methods. And it's what we just said. If you have a function in terms of y, find this in your book and make a note in your notes. Make sure you study that page, because these 4 illustrations just sum up everything I just said. First, I look at my differential. My function's in terms of what? If my function's in terms of y, then I want to use horizontal rectangles. You see, this is in terms of y, horizontal. This is in terms of y, horizontal. This is in terms of x, vertical. This is in terms of x, vertical. So far, so good? In terms of y, horizontal. In terms of x, vertical. All right. Then you look at your axis of revolution and just say, now that I know which way I want my rectangles to be, what's the relationship between my rectangles and my axis of revolution? If I'm using vertical rectangles around a vertical axis of revolution, then I'm going to have to use the shell method because my rectangles are parallel to the axis of revolution. If I use a horizontal rectangle, what was I trying to say? I use a vertical rectangle around a vertical axis, that's shell, or horizontal rectangle around a horizontal axis of revolution, that's shell. But horizontal around the vertical or vertical around the horizontal, that's disc. Other place that is summed up, I don't know if you've printed that yet, but I have a whole page in Momentum, overview of disc / washer. Washer is just a disc with a hole in it. Overview of that and the shell methods. I'm not going to reread all that to you, but I would read it very slowly tonight if I were you. Just, yeah, okay. I don't like it, but I kind of get it. I'm going to keep reading it slowly until I understand. All right, so maybe we have time to start. Number 30 says choose your method. So there'll be a couple problems on the test that say choose your method. Number 30 says y equals x cubed. That's easy to solve for x if I need to, so yay, I can go either method on that. Y equals 0, x equals 2. And I'm going to go ahead and say when x is 0, y is 0, and when x is 2, y is 8. That stays the same for A, B, and C parts. Dang it, I'm doing number 29. I don't mean to be doing number 29. I want to do your homework problem. Let's try that again. Number 30, y equals 10 over x squared. A little bit less fun to solve for x, but I could do it. Y equals 0, x equals 1, and x equals 5. So it looks like the even one's a little bit harder. You get a little bit easier when you're in homework. All right. What would make y equal 0? We're trying to get 3 ordered pairs out of this. What would make y equal 0? Y is a fraction of 10 in the numerator. Is there any way to make a fraction with 10 in the numerator equal 0? No. So that's the x-axis, but the graph's not going to touch the x-axis. It's easier to see when x equals 1, y equals 10, and when x equals 5, y would be 10 over 25, which is 2/5. And I'm going to redraw that graph in each part because each part has a different axis of revolution. But the A part says revolve around the x-axis. Oh, okay. So, revolve around the x-axis. That means my axis of revolution is what? Horizontal or vertical? X-axis is horizontal. But you can't spell all of a sudden. Horizontal. If I'm using horizontal rectangles, does my function need to be in terms of x or in terms of y? In terms of y, could we get this in terms of y pretty easily? Yeah, it wouldn't be bad. X would be the square root of 10 over y. Yep. And so we have a function in terms of y. We have horizontal rectangles around a horizontal axis. Is that going to be disk method or shell method? No. If your rectangles are parallel to the axis, then it's the shell method. And the volume in the shell method begins 2 pi. Oh, I didn't graph it. Let's see. From 110 to 5 2/5 divided by x equals 1 and x equals 5. And that's what I'm rotating. On x-axis with horizontal rectangles, and the picture helps me so much. Because then I can see that my rectangles are sliding from bottom to top. What does that mean I need to integrate from? 0 to 10. Does that make sense? What is at the center of each rectangle? They're sliding up. So right here, the center of the rectangle might be a half. Right here, it might be 1. Up here, it might be 8. Are those y values or x values? They're y values. So the center of each rectangle is at some y. And then the height of each rectangle is what's the rectangle touching on the right, what's it touching on the left. So horizontal looks like length instead of height, but how would you find the height? H equals, it's touching square root of 10 over y on the right, and it's touching x equals 1 on the left. What's this rectangle touching on the right? It's touching the function in terms of y. What's the left end of the rectangle touching? X equals 1. It's always just what's the right side touching minus what's the left side touching, or for a vertical rectangle, what's the top touching minus what's the bottom touching. So y is the radius of the shell, square root of 10 over y minus 1 is the height of each shell, and then what's the thickness of each shell? dy.
How do you determine the horizontal?
Let's see. My thought process was going about the x-axis. How did I decide that? The question was, how did I decide horizontal rectangles, right? I don't have a thought process. Horizontal rectangles means in terms of y, And then I said, that function in terms of y and my horizontal rectangles and my axis of revolution being, it's the fact that it's in terms of, well, it was in terms of x though. It was in terms of x. Okay, this method you would have used vertical rectangles. They would have been perpendicular to the axis, and maybe that one would have been about equally easy. Last night I did it with the disk method. Yep. Last night I did it with the disk method, and it worked just fine. Okay. So sometimes it's going to be a toss-up, and then sometimes there's a clear error that would be hard to solve for x, or that would be hard to solve for y. Yes, it's only Tuesday. All right. Homework is finish up whatever you have not done, 1 through 29. And sometime I need to take up homework, or I can just give you